Bismillahirrahmanirrahim. In previous lecture we have studied about the problems using analytical formulas, stress problems up to problem number 925. In this lecture uh, started we will start it from the lecture from the problem number 926. So what does problem number 926 states? It states that if an element is subjected to the state of stress as shown in the figure, find the principal stresses. Also compute the stresses components on a plane at 30 degree counterclockwise from x-axis. So you need to determine what principal stress is and maximum in-plane shearing stress is, and normal and shear stress at an angle 30 degree counterclockwise from x-axis. For this you need to do first what principal. In order to determine principal stresses, we know the formula for principal stress: sigma 1 sigma 2 is equal to sigma x plus sigma y divided by 2 plus minus under root sigma x minus sigma y divided by 2 whole square plus tau xy whole square. What is the value of sigma x? It is 4000 psi and it is a tensile. What is the value of sigma y? It is 8000 psi compressive, therefore a negative sign, divided by 2 plus minus. If you put the values of sigma x, sigma y, you got this answer. So sigma 1 will be equal to minus 2000 plus 8485. So we will get the value of sigma 1 as 6485 psi, and sigma 2 will be equal to this minus 2000 minus this, you get 10485 psi. Similarly, maximum in plane shearing stress will be equal to plus minus r, so plus minus 8485 psi, and the value of normal stress at 30 degree will be equal to what? We know that the formula for normal stress is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cos 2 theta minus 2xy sin 2 theta. So what are those values? 4000 minus 8000 divided by 2 plus 4000 plus this minus will become plus, and cos 60. So we have the normal stress value at 30 degrees equal to plus 5196.15 psi, and the value of shear stress at 30 degrees is equal to what? Putting the values of theta, sigma x, sigma y, tau xy in shear stress formula, we will get this value tau 30 at this. Similarly, we can find the principal plane, which is equal to tangent 2 theta b is equal to minus 2 tau xy divided by sigma x minus sigma y, which is equal to minus 2 into minus 6000 divided by 4000 plus 8000. You get the answer. Tangent 2 theta is equal to 1, and 2 theta will be equal to tangent inverse of 1. 2 theta is equal to 45. Theta is equal to 22.5 degree. So at 22.5 degree you have principal plane. What is the value of principal stress? Sigma 1 6485. What is the value of sigma 2? 104, and there will be no shear stress on principal plane. And what is the value of maximum in plane shearing plane? It will be at 45 of this, so we will add 45 to this and we can find the value of shear stress. And at 30 degree you are already determined the normal and shear stress values. At 30 degree your normal stress was 6200, at this point it was minus 10, and shear stress was plus minus r. So this clockwise here, this anti-clockwise. Now let's go to the problem number 927, which states that for the state of stress shown in figure this, determine the principal stresses and the maximum in-plane shearing stresses. Show all results on a complete differential sketch. So if we have been given with there is no sigma x, the value of sigma y is 60 megapascal tensile, tau xy is counterclockwise, therefore tau xy will be equal to minus 30 megapascal, and tau yx will be equal to plus 30 megapascal. You need to determine what principal stresses sigma 1 and sigma 2, and also maximum in plane shearing stresses tau max minimum, and then you need to draw the complete sketch of differential element. So in order to determine principal stresses, what is the formula for sigma 1 sigma 2? That is equal to sigma x plus sigma y divided by 2 plus minus sigma x minus sigma y divided by 2 whole square plus tau xy whole square. Value of sigma x is equal to 0, whereas sigma y is what? 60 megapascal, and tau xy is minus 30 megapascal. Putting those values, sigma x is equal to 0, sigma y is equal to 60 divided by 2, and tau xy minus 30 whole square. We have the value of sigma 1 is equal to 72.42 megapascal, and we have the value of sigma 2 is equal to 30 minus 42.42 s minus 12.42 megapascal. Now we can determine the value of a principal plane also, which is minus 2 tau xy divided by sigma x minus sigma y. So putting those values, minus into minus 30 divided by minus 30, we have got the answer as 2 theta p is equal to tan inverse of 1, which is 40 minus 45 degree. Theta p is equal to minus 22.5 degree. This shows that a clockwise angle from x-axis. Negative sign shows that angle is measured clockwise from x-axis. Now this negative sign shows that the angle will be measured clockwise. Maximum plane shearing stress, you can use the formula tau max equal to plus minus r. We got the values 42.4 to 6 megapascal. Normal stress is, as we know that there will be no stress on principal plane, shear stress, whereas there will be a normal stress equal to average stress at maximum in plane shearing stresses. So we will find that sigma n is equal to sigma x plus sigma y divided by 2 is equal to this, and plane of maximum shearing stress is at 45 degree to the principal plane, so we will have minus 67.5 degree. Now we will draw the sketch. The element will be rotated clockwise. When you rotate the clockwise element, this first will be the sigma 1 and the other one will be sigma 2. So you have sigma 1 is equal to 72.42 megapascal and sigma 2 is equal to minus 12.42. And in order to draw about the maximum shearing plane, you will need to go to what, 22 plus 5 plus 45 degree, rotate that element, and at that element what is the normal stress, 30 megapascal, and what will be the tau max. For the tau max, as we know that this is your sigma 1 or the main axis, so first positive value tau max will be 42.4 clockwise here and anti-clockwise here. Problem number 928. For problem number 928, we have the given state of stress as sigma 1. Principal stresses are given, which is sigma 1 is equal to sigma x is equal to 40 megapascal, sigma 2 is equal to sigma y is equal to minus 30 megapascal. You need to determine the stresses at 30 degree and 120 degree. So 30 degree will be equal to what, sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cos minus. As we know that there will be no shear stress on principal plane, this is equal to 0. This sigma x is sigma 1, sigma y is what, sigma 2. We got the values of sigma 30 as this, sigma 120 as this. Similarly, shear stress, putting the value in shear stress formula, we get the value of tau 30 is equal to 30.31 megapascal and tau 120 is equal to minus 30.31 megapascal. We can draw that differential element as well. Rotate the element at 30 degree, you get the value of sigma, which is 22.5 megapascal, and at 90 degree to this we have 12.5 megapascal. Then we have shear 30.31, etc. So thank you. We have already solved various problems of analytical problems, and assignment has already been given to you, so you need to solve all these exercise problems. Solutions are already been given to you. Follow those steps, watch this lecture. This will help you in solving the other problems. Thank you very much.